Hello and welcome to the final example on um, differentiation. Basically, we'll look at the trig function of differentiation. So let's try to solve this particular problem. Of course, if you observe this very well, I can see a quotient rule and also a chain rule here from the concept of length initially. When you have two things dividing, quotient rule comes to mind. And when you have a term in the bracket and it is being raised to a particular power, chain rule comes to mind. But basically, the main priority is chain rule, because everything here boils down on this power. So everything here was being encased to a particular power. So this is a chain rule question. But in this chain rule, a quotient rule is present. So let's start. I'll call the term in brackets, call it u. So let u to be equal to term in brackets, please. Term in bracket are what? Are 2 exponential x plus 5 over 6x to the power 5 minus 3. Differentiate u with x. I'll have du over the x as being equal to, differentiate this. To differentiate this one, I have to apply quotient rule. So now let me just pick this out separately. So I have 2 exponential x plus 5 over 6x to the power 5 minus 3. So call this one u, call this v. So we're saying that u is equal to 2 exponential x plus 5 du dx is equal to 2 exponential x. Next up, we said v should be equal to 6x to the power 5 minus 3. The v dx is equal to 30x to the power 4. So I have this. Now using quotient rule, using quotient rule, I expect that you know this, right? I expect you know this. Using quotient rule, I'll have that v du over dx minus u dv over dx all over v squared. From here, what's v? V is this guy here. Let me put it down. This is now equal to v is 6x to the power 5 minus 3. That's my v. Multiplied by u dx. U dx is 2 exponential x minus, what's u? Of course, u is 2 exponential x plus 5. The v dx is of course 30x to the power 4, right? So all over v squared. So my v is of course 6x to the power 5 minus 3. That's v, but a square was there, so a square. So on differentiating, listen up please. On differentiating this one alone, I had everything here. So I'll plug in this answer here. So my answer becomes 6x to the power 5 minus 3 into 2 exponential x minus 2 exponential x plus 5 into 30x to the power 4. So all over 6x to the power 5 minus 3 all squared. So differentiate this one here. I have this as my answer. Proceeding from here, y is now equal to the term in bracket here was called u. So I have u to the power 7. Differentiate y with u. So I'll have the y over the u is equal to 7u to the power 6. apply the general method, multiply by the power and subtract from the power, general method. So I have this one here. For me now, I'm done. So I'll apply chain rule using chain rule. So I have to clean. So this working. So you can just do it if you want to. Perhaps if you don't need it, just do it quickly in a rough sheet and put your answer the way I did. So I'll erase this. This is off. Alright. From then now, using chain rule. So using chain rule. For chain rule, we said that the y over the x is equal to the y over the u times the u over the x. This is now equal to the y the u is 7u to the power 6 times the u the x is everything here. So I have 6x to the power 5 minus 3 into 2 exponential x minus 2 exponential x plus 5 into 30x to the power 4 all over 6x to the power 5 minus 3, 6x to the power 5 minus 3 squared. So I have this. That's my the y over the x. But here's the concept. The y over the x. Here's the concept. I can express x in terms of u. So what's this u itself? U is this value. So my final answer becomes 7u is everything here. That's 2 exponential x plus 5 over 6x to the power 5 minus, that's u to the power 6. Then repeat this one here. That's 6x to the power 5 minus 3 into 2 exponential x minus 2 exponential x plus 5 into 30x to the power 4. Alright, so all over 6x to the power 5 minus 3 all square. So this is my answer after solving this particular question. So as I solve this question, alright, if you want to, you can just use this to expand this. Use this to expand this if you want to. I can leave it this way. Alright, as I solve this particular question. So let's do the trig function of differentiation in our next class.